Hello everyone, today is day 22 of solving a Leetcode problem every day. So today I'm going to be solving reorder list, which is another linked list problem. So you are given the head of a singly linked list. The list can be represented as L0 to L1, then dot dot dot, Ln minus 1 to Ln, where Ln is the last element in the list. So you want to reorder the list, so pretty much you alternate between elements from the beginning of the list, for the first half of the list, and all elements from the last half of the list. So for example, you start out with the first element, then you take the last element. Then you go back to this element, and then you take the element before the last element, and so on and so forth. So it says you may not modify the values in the list nodes, only nodes themselves may be changed. So another thing is you got to use the nodes themselves. You can't create new nodes or edit the nodes values. So over here we have 1, 2, 3, 4. So we get 1, 4, 2, 3, 1, 4, 2, 3. Then here we have 1, 2, 3, 4, 5. So we go 1, 5, 2, 4, 3. So cool. This is how I solved the problem. So I started out by separating the list into two halves. And the way I did this was by using a fast and slow pointer. So the slow pointer gets initialized to be uh, the head of the list, and then the fast pointer gets initialized to be the second element in the list. So as you can see, the fast pointer gets incremented by 2 positions each time, and the slow pointer gets incremented by just 1. So here we have the slow pointer, here we have the fast pointer. We increment the fast pointer by 2, so now it's on 4, but we increment the slow pointer by 1, so now it's on 2. So now fast.next isn't true anymore, so we know that fast has reached the end of the list, and now the slow pointer is on 2, which can pretty much be considered the middle of the list. The same thing with here. Slow pointer starts at 1, fast pointer starts at 2, increment the fast pointer by 2, so it ends up on 4, but slow pointer by 1, so it ends up on 2. Now you do that again, and fast pointer becomes none, but the slow pointer gets incremented to 3, which is smack in the middle of the list. So basically this very first part is just to have a pointer in the middle of the list, which is going to be our slow pointer. Now, this is the part where we're pretty much splitting the list into two halves. So we say second equals slow.next, which is the beginning of the second half of the list. So if, for example, with our first test case, slow ended up here, so second would be 3, the beginning of the second half. And in this case, slow was 3, so it would be slow.next, which would be 4, which is the second half of the list. Now, what we're doing with the second half of the list here is just reversing it. So I already have a video specifically on how to reverse a linked list iteratively and recursively. So if you want to understand more about how this part works, just watch that video. Then anyways, also we say slow.next is equal to none here because what we're doing is we're disconnecting the two halves of the array. So we're getting rid of this pointer and getting rid of this pointer right here. And the reason is we don't want to cause a loop in the end. So we're just basically doing some cleanup. Then over here we have our first pointer to the beginning of the first half of the list, and our second pointer, which is a beginning to the second half of the list, which is now in reverse order. So in this case, we'd have 1 and 2 as the first half of the list, and then we'd have 4 and 3 as the second half of the list because we've reversed it. In this case, we'd have 5 and 4 and 1 and 2. And basically what happens is we take this first element and we set its next node to be the very first element in the second half of the list, which would be 4. So now 1 points to 4, and then 4 points to 2. And Here we're just creating temporary pointers so we don't, because for example, we can't just directly set first dot next to be second, because if we were to do that, we'd lose the pointer to 2 and then it would just be lost. So we create a temporary pointer for both 2 and for 3, because we're also setting second dot next to be the very first temporary pointer, which is first dot next, so we don't want to lose second dot next either, which is why we're creating these temporary pointers. So this is the optimal solution. So this is going to be linear time for time complexity, and the reason why is because each of these while loops is going to at most run n times, and honestly none of them are going to run n times, because for example this is going to run like n over 2 times, because the fast pointer is moving twice each time, so we're not even processing every single element. And then in this case, this is only the second half of the array, so again it's only half the array that's being processed. And then here it's the same thing again. We have 2 arrays, so we're processing basically 2 elements at once. But yeah, the point is that this runs in linear time, and then the space complexity is just constant because we're not using any extra space. Now, one thing I want to note is when I actually solved this myself, I didn't use this fast and slow pointer technique. I solved this in linear time, but my time complexity was linear time, but my space complexity was also linear instead of constant. And the reason why is the way I solved this was I just stuck all the elements in the linked list to an array. And the reason why I did that is this would allow us to access elements by the index. And once you have all the elements in the array, it's really easy to just put it in this order, because you can just take elements from their certain positions instead of having pointers, and it kind of saves you a headache. But the downside to that solution is that it does take extra memory, which is event. But yeah, that's my solution for the day.